Hi guys, welcome to the lecture. So today's topic is application of differential equation in a real life. So today let us discuss this. Okay, let us start our lecture. So here I have taken one ball and I am going to throw it. So I have thrown a ball. Now my question is nothing but what is the distance traveled by this ball? Okay, so how much distance I have thrown it. Okay, so interesting, right? How to find without measuring with a thread or any instrument. Okay, so how to find? So I'm going to use a differential equation for solving this problem, this real life problem. Okay, before that I am going to explain some terms which I am going to use in this uh, class. Okay, so G is nothing but acceleration due to gravity. I have taken. X is nothing but time taken by the ball. Next, Y is the distance traveled by the ball, which we are going to find now. Okay, so as you know, according to the physics laws, acceleration due to gravity, what is it? 9.8, right? So acceleration due to gravity is a constant. So here I have used the word acceleration. Here acceleration, we represent acceleration in mathematical terms as second derivative. Okay, so acceleration is represented with second derivative. So I have represented d square y by dx square. So if you solve this equation, I can find the distance traveled, right? Why? Because I have taken y here and x time I have taken here, and acceleration due to gravity I have taken here. Okay, so let us solve this equation. Okay, so how to solve this? I have to remove derivatives from this equation. Okay, how to remove it? Opposite to this is nothing but integration. So let us apply integration for this. Integral d square y by dx square with respect to what I have to do? With respect to dx I have to do. Is equal to integral g dx. Okay, so implies if you apply a derivative integral for the second derivative, it will convert into dy by dx, first derivative. It will convert into first derivative. Next, g into integral constant is nothing but x plus some integral constant will get c1. Implies again one more derivative is remained in this equation. So to solve this, again I am going to integrate on both sides. So integral dy by dx with respect to dx is equal to, so g integral x dx plus integral c1 dx plus some integral constant I have to make. So I am taking it as c2. Okay, implies, sorry, so this we will put in the next step. Okay, so if you apply integral for the first derivative, what you'll get? The dependent variable y is equal to, what is integral of x? We get x square. Okay, g into x square by 2, correct, plus c1 x, integral of constant is this, plus c2, correct. So this is our required equation for finding distance traveled by the ball. Okay, so what is this equation? So if you observe, if you recap this moment, so in which path it has traveled? It has traveled in this path, right? in a curved shape. Okay, this curved shape is nothing but a parabola. What is this equation? It's the equation of parabola, right? Quadratic equations always represent parabolic equations. Okay, this curve will give a parabola. Okay, now how to find the distance? That is our main theme, right, for this lecture. So, how to find this? At particular time. So, usually in differential equation gives the solutions in such a way that at particular spot you can find. So, whatever the time taken by the ball or taken by the object, at any time you can calculate. So, that's why you can take x value as any number of seconds or any number of minutes. Okay, so at particular time you can find the distance traveled by the ball. Okay, so in this way you can find distance traveled by the ball using a differential equation. This is one of the best example that I can give as an example for application of differential equation in a real life. So thank you for watching my lecture. So keep watching. So please comment whichever the lessons you want to post. I will try to do it in my channel. Thank you.